We're going to talk about trig functions, trigonometric functions, and I'm going to go through it pretty quick because there's a lot to cover. The nice thing about videos is you can back it up, watch it again, look at something and say, now how did he get that? But in every case, I'm going to the unit circle, and so I'm just going to draw it over here. And here's a point T on the unit circle, and it has an x coordinate right there and a y coordinate right there. And this is how we define our trig functions. We have the sine of t is equal to y. We have the cosine of t is equal to x. We have the tangent of t is equal to y over x, which is also the sine over the cosine. Then we have three more functions that are just the flip of these guys. For example, we have the cosecant of t, CSC for cosecant, and that is equal to 1 over y. We have the secant of t, which is 1 over x. And then we finally have the cotangent of t, which is x over y. So all of our functions have to do with the x and y coordinate that t is. And let's just draw an arrow again and say x and y, and those are the x's and y's that we're talking about. You notice I'm very careful right now. I'm not saying the sine of x. I'm not saying the cosine of x or the tangent of x. Eventually we will, but right now I'm talking t because I want you to think of t as being a point on this unit circle. So, let us now make a little chart. So I have the sine of t, the cosine of t, the tangent of t, the cotangent of t, let's put that there, then the cosecant of t and the secant of t. And now I'm going to do for points on the unit circle. I'm going to do for 0, which is when t is right there. I'm going to do for pi over 6, which is when t is right there, 1/6 of the way to the half circle. I'm going to do pi over 4, which is right there at the midpoint of that arc. I'm going to do pi over 3, which is right kind of where t is right now, but that's going to be the 60-degree mark. And then I'm going to do pi over 2, which you should recognize by now as being 90 degrees. The sine of t, when t is 0, let's put a t right there. When t is 0, my y value, the height from the x-axis, my y value is 0. Remember, my sine of t is y. In this case, in this point right here, my y value is 0. My cosine, though, is this whole x value, which is 1. My tangent is y over x, which is 0 over 1, so it's 0. My cotangent, though, is 1 over 0. It's x over y, 1 over 0. 1 divided by 0, undefined, scratch that, doesn't exist. Okay? Watch again if you need to, but the cotangent of 0 does not exist. There's no number. Cosecant is 1 over y, 1 over 0, again, doesn't exist. Secant is 1 over x, In this case, it's 1 over 1, and it's 1. Let's go to pi over 6 up here. Now I know, and you should check yourself, this distance here for x is square root of 3 over 2, and this distance for y is 1/2. For that point t equal to pi 6. Again, back up if you need to, verify it yourself. My sine is going to be that y value, 1/2. My cosine is that square root of 3 over 2. My tangent is the y divided by x, which is 1/2 divided by square root of 3 over 2. The 2's cancel, and I'm left with 1 over the square root of 3. On my cotangent, it's the flip of that. It's going to be the square root of 3 over 1, or square root of 3. Cosecant is going to be 1 over y, which is 1 over 1/2, which is 2. Secant is the flip of square root of 3 over 2 is going to be 2 over the square root of 3. Time's running out, but I'm going to start going fast. Pi fourths. Let's do some erasing here. So here's my new x and y. That, as you know from your 45-45 triangle, which you've already seen, I hope, the video on that, that's going to be 1 over the square root of 2, and the height is going to be 1 over the square root of 2. So my y value, my sine, is 1 over the square root of 2. Same with my cosine, they're the very same value. Because of the very same value, y over x is going to be 1. Verify that. 1 over the square root of 2 divided by 1 over the square root of 2, it's 1. Same with my cotangent. It's the same fraction. Cosecant is going to be the flip of the sine, which is going to be the square root of 2, and the secant is also going to be the square root of 2. We're almost done. Pi thirds, that's going to mimic what we did with pi 6, except it's going to be backwards. What was the sine is now the cosine, and what was the cosine is now the sine. The tangent is going to be the y over x, which is going to be square root of 3 over 1, which is square root of 3. The cotangent is going to be the flip of that, 1 over the square root of 3. The cosecant is going to be 1 over the sine, which is 2 over the square root of 3. And the secant is going to be the flip of the cosine, which is going to be 2. 2 over 1. Finally, we get to pi halves. This one's pretty easy because my t value is 0, 1. That's my coordinate. So my y value, my sine, is 1. My cosine is 0. My tangent, y over x, is going to be 1 divided by 0. It doesn't exist. Scratch. Cotangent, however, is going to be 0 divided by 1. That's 0. No problem. Cosecant is going to be 1 over the y value, which is 1 over 1, which is 1. And the secant is going to be 1 over 0, which is undefined. So you will see this is something I'm not expecting you to memorize, but I didn't come up with these numbers because I memorized them. I came up with them because I was looking for what are x and y, and how do these relate to each other with these functions. So the thing to memorize, if you have to memorize, but I think you ought to just know it, is that the sine is equal to y, cosine is equal to x, and the tangent is equal to y over x, and everything else is the flip of it.